All right.
Okay, so what I'm exactly asking is like, is there like a stipulated way we should perform? Like, should we just do it on our own, like how we want to
Yes,
analyze
how
the
you
data
want
set?
to. It's self-paced. How you want to analyze your data set. So that's why I said if you feel that you can make use of other languages like Wolfram or Python, if you feel like you can also use that to perform. But what we are interested in is that you submit your codes at the end of the day. Do you understand?
Okay. Yes. Okay, now, thank you very much. Exactly, like, is there like a stipulated way we should perform? Like, should we just do it on our own, like how we want to?
Yes, how you want to. It's self-based. How you want to analyze your data set. So that's why I said if you feel that you can make use of other languages like Wolfram or Python, if you feel like you can also use that to perform. But what we are interested in is that you submit your codes at the end of the day. Do you understand?
Thank you very much.
All right. So want to.
Hello, can you hear me? Hello?
I can hear you, Fumilayo. Yeah, I can hear you. Can you hear me?
Yes, I can hear you now. Good evening.
Yeah, good evening.
Okay. I have like two questions. One, the prerequisite course, is it going to be part of our assessment? Or we can take that with
Yeah, so the instruction is that you are in, I can hear you. Can you hear me?
Yes, I can hear you.
Yeah, the instruction is that you are encouraged to take the prerequisite course, but it's not part of your assessment.
One, the prerequisite course, is it going to be part of our assessment? Or we can take that with
Yeah, so the instruction is that you are in. Yeah, I can hear you. Can you hear me?
Yes, I can hear you.
Yeah, the instruction is that you are encouraged to take the prerequisite course, but it's not part of your assessment. I think it's better I switch to the manual mode. So let me see if there are other hands. Yeah, I've unmuted Ita. So you can talk now. Okay. I think it's better I switch to the manual mode. So let me see if there are.
Hello, can you hear me?
I can hear you. Can you hear me?
Okay, yes. Good afternoon. I have a question, like the code that's given to us for the introduction, like for us as beginners,
yes.
I don't really seem to understand some of them. Well, I'm going through some other courses.
Hello, can you hear me?
Courses.
I can hear you.
Okay, yes. Good afternoon. Like it's echoing.
Yeah,
I have a question, like the code that's given to us for the introduction, like for us as beginners,
yes.
I don't really seem to understand some of them. Well, I'm going through some other courses.
Hello, can you hear me?
Course.
Good afternoon, everyone. Apologies about the technical glitch. We're trying to, our guest, Wale Akinfaderin, is trying to connect and is going to be with us in a bit. If you do not mind, we'll take a second just to sort the technical glitch out, and you'll be in. Okay, so thankfully, Wale is with us. Apologies about the late start. Apologies about the technical glitch. So I'm going to hand control over now. You can introduce Wale and we can get started. Never mind, you've not have missed anything from the session. We're going to ensure we make the most of it and you learn as much as you can. Please don't forget to drop your questions on Slido, and we're going to have enough time to address them. Thank you.
Yeah, the time you've all been waiting for, it's time to turn the table over to Wale Akinfaderin. Wale is a data scientist at Amazon Web Services. He has broad experience in implementing and extending machine learning techniques to solve practical and business problems. He's an advocate of open source and democratizing learning and has presented in technical conferences. In his spare time, he conducts research on machine learning for the developing world. Yeah, the time you've all been waiting for. It's time to turn the table over to Wale Akinfaderin. He also advises startups in data science and artificial intelligence space. He has the next voice to be hearing now will be Wale, and I urge you to get your pens ready because the table is about to be broken. Thank you, Wale. Now over to you. And democratizing learning, and has presented in technical.
Hello everyone. If you're on video and you can hear me, just wave your hand. Okay. All right, that's good. It looks like almost everyone can hear me. Yeah. We've had some technical glitches in the last I think 15-20 minutes. There's so many of you that I couldn't even get in. So the Zoom call was actually maxed, but now I'm actually pretty glad that I am here. So I'm actually a data scientist. I work in big tech. Before joining Amazon, I actually worked in energy utilities. I was leading a team of data scientists working to use data science to improve renewable energy. And then before that, I worked in retail a little bit, solving data science and machine learning problems. So I've been doing data science and machine learning for about half a decade now, about five years or so. And I know you guys started on Thursday, and I'm sure there's so many things to learn. And just the rapid pace, but I'm sure you guys will be good. The first module is Python for data science, and I'll just go into a little bit of explanation about why I think it's actually really good for you to learn Python for data science, and then after that I will go into some code session, just walk you guys through a few things. So Python is good because one, it's open source, and you guys don't want to use tools that you'd have to pay for. I mean, because some of the licenses they're very expensive, and also Python is actually the fastest growing language for data science. Almost everybody uses it, and it's open source. Everybody contributes to it, and then also a lot of the libraries, a lot of the data science machine learning models in production, they actually use Python. So Google has TensorFlow. Facebook has something called PyTorch, and then there's scikit-learn. So everything, they're mostly written in Python. So Python is extremely good. It's also good for you if you want to do end-to-end data science projects. So if you want from taking your data, wrangling your data, doing some exploratory data analysis, building your model. You could even build pipelines to read data from a database with Python, and then down to you productionizing your model. So you could actually use Python all through. So that's why I think Python is extremely good. And that's why we wanted you guys to learn Python, to understand Python, to know how to write functions with Python, but at the same time, how to use Python for data analysis. So there are a lot of tools or libraries that were introduced. So there's NumPy, and then there's Pandas, and then there are also other visualization tools. So Pandas is also pretty good for wrangling data. NumPy is another language that is good. So I would actually just go. I would go right now and just open a session, and then we'll just go through NumPy a little bit, and then hopefully we can go on and do other stuff. Okay. So let me see. I want to actually share my screen. Okay, looks like I'm sharing my screen now. So what I want to do is I actually want to open Jupyter Lab. Okay, so let's open just a new Python notebook. I assume a lot of you already know how to use Jupyter Lab. Let me rename it as Amboye session. Actually, don't need that for now. So let's go. I think so. Let's just start with the Markdown, and so these will actually do introduction to NumPy. And the first thing you want to always do is when you're writing code. One thing I tell people is that it's always good for you to always comment. And it's always good to comment and say, okay, now you're actually you're importing your library, and then I can go and say import NumPy as MP. So I have that. So now I've imported. And then now the next thing we want to do is that we want to create an array. So so Python is actually an ND array. So which means it could be a one-dimensional array or a two-dimensional array. An array are just numbers. So you could have, just think of it of you having like a length of just one number. That's just, let's say you have a matrix or something. And I'm going to show you guys. So the next is, and the reason why Python NumPy is pretty good is that sometimes when you have data, you can actually work with numeric data. You can work with strings. It's good for you to maybe slice your data, for you to do some wranglings, for you to do a lot of things, and it is much more faster, for example, than Python, than Pandas or other libraries. So let's create an array. Let me call the name of the array as Amway, and then so you just do mp.array, and let's say I'm creating an array of odd numbers, 7, 9, and 11. Let's say the first 5 odd numbers, right? And then I've created the array. I can come here and say, let me see array. And then I'm actually gonna say, I think I need to drop this because it's distracting. Okay, so you guys can see now I've actually created an array. And also, I actually want to see the type of array that I'm creating. And then I can go and say type.array, and it tells me that it's an ND array. One good thing about array about NumPy is that you can actually also slice. You can slice through the arrays. You can slice through the arrays. So you could say, let me take the first 3 numbers, right? And so typically, because the name of the array is the array, you can actually use this to slice through the array. And then you actually see the first 3 numbers, which is 2, 3, and 5. And then you could also go and say that you want to see what's happening from the back. And then it will give you the last 3 numbers. And then another thing you could do is that you can also slice in between arrays. So you could say that, what if you take this? And what this is doing is that, because I have 5 and 2 and 4, so it actually uses like 0, 1, and 2. So it takes this, right? And then so it actually gives you 2 and 4. So in between 2 and 4 is 3. So it takes the number. It takes it's 3 and 4. So it takes this, the third one, and then it takes the fourth one. So if you take 2 and 4, the ones, it doesn't take the second one, but it's just the third and the fourth one. And then you could also see the same thing. Let's say if I do 3, 5, right? And in this case, I expect a 7 and a 9, which are same. So and then another thing you could do also is that typically you could point to, you can say you have this array and you actually want to get maybe so it goes 0, 1, so I say we're going to see what the fourth is, and which is number 4. Not this, sorry, which is this. And then you see, so it's 0, 1, 2, 3, 4, and 5. So which is there. And then another thing you could do is that you could actually replace a number inside the array. So you could come and say that if, let me do this, and say that array 1, right? So array 4 is 9, right? And I actually want to come here and say I actually want to replace that with, let's say I want to replace it with 26, for example. And then I can come and see what it is. Now I can see that 99 has actually been replaced. So you can replace numbers inside an array. So that's that. Just a quick walkthrough of a one-dimensional array. I'm actually just going to go through what a two-dimensional array is quickly. And for two-dimensional arrays, they're also very similar. And so you could actually have, so let me say, let me call it array2, and then I could say this is now I have 1. So I'm actually just going to do this, which is actually odd, and then I'm also going to do this, which is a set of even numbers, for example. One thing, and then I should actually have, because it's a two-dimensional array, I should have 2 brackets covering it. One thing that I actually missed is I could say that I want it to be floats. To floats more of numbers with decimal points. I could make it integers. So I have this. And now I have my two-dimensional array, and I could actually say, let me see what my two-dimensional arrays are. And you could see with that I've actually made a two-dimensional array that looks like a matrix with 4 columns and 2 rows. The good thing also is that I could take this and I can actually use, like I did with the one-dimensional array, I can say that I want a certain number. So remember when I said that you have, so just think of the row, right? So you have 2 rows. So the 2 rows are going to be in the indices are going to be 0 and 1. And then for the column, the indices are 0, 1, 2, 3, right? So if I do Amoye_2 and I do 1 and 2, right? I think I would expect me to get number 6 because 0 and 1, 0, 1, 2. So I should expect me to get 6. And then let's see if I do if I do 1 and 0, now I'm actually gonna check. Oh, where's the stuff? I actually want to check. I'm trying to find where I can actually check the chart. Okay, I can see the chart now. Yeah, if I do this, what am I gonna get? You can actually, you should be able to type in the chat. So I just want to make sure. Okay, I can see. Okay, 2.0. Yeah, thanks, Deborah. Yeah, okay, everybody's in. Okay, what if I do this? What am I gonna get? Okay, yep, that's what I'm gonna get. I'm gonna get an index error because now I have too many indices because there's no 4. Okay, great, let's go. So yeah, I don't need that. Actually I should do this. So what if so if I do this, for example, so 0 underscore with this these columns, I'm actually gonna get just the first row of it. And then if I do, so this represents row and this represents columns. So if I do this, for example, which is let's say, let me do this. So I'm going to get 5 and 6. So now I'm actually just showing the columns. So which is this 5 and 6. This is a little bit tricky, and I'm actually looking at the screen, the charts to see if someone is gonna get it. So who knows what I'm gonna get if I do this? One says 7 and 5. Still no right answer. Okay, finally, I think someone got it. Thanks, Brian. Yeah, so actually, this is what I'm gonna get. I'm gonna get 6 and 8, and I'm gonna tell you guys what I just did, right? So I have -1, and I have this. So what -1 does is that it actually comes from the back. So let's say, for example, so the first part is actually my rows, and I have 1, 3, 5. So my rows is actually 0, 1. So -1 is actually going to be the back. So the idea of using negative when you're trying to to index NP arrays is that you're starting from the back, right? So -1 is just going to be the row below, right? And then my -2 is actually going to be, so I have for my columns, I have 0, 1, 2, 3. So it's going to be the last two, which is 2 and 3. And so that's why it's actually -6 and 8. Am I able to? Yes. Okay. Let's see. Okay. This is much bigger now, right? Okay. Yeah. So yeah, so that's why and then another thing also is in typical in data science project, it's always good for you to check the shape of whatever you're doing. The shape actually gives you what yeah, someone said I should go the slides in, I should go through that, right? So let's just come back again and do this so we can see what it is exactly. And then I had this and I had this. So for this, I have -1 is actually, so the rows are 0 and 1. And so -1 just takes the last one, right? Which is, so the negative comes from the back, right? And so -2, what it does is that it takes the last two columns. So this side represent the row and this side represent the column, right? So if I have, for example, if I have a -1, -1, right? You would see that all I'm just gonna get is 8. If I have a -1, -2, I'm gonna get 6 and 8. If I have a -1, -3, because it's the last 3, I'm actually gonna get a 4, 6, 8, right? Now, if I have a -2, -3, what do you guys think I'm gonna get? You don't need to give me exactly. I shouldn't get an error. You can just tell me how many what dimension it's gonna be. No, nobody is close to it. I'm actually gonna get a 2-dimensional matrix now. You could see exactly. So you see that now I accept 1 and 2 exactly. So the -2 means that, and this column means I'm taking the last two. I mean, I have basically 2 rows, right? So if I do -3, I'll get an error. I should get an error, but it's not giving me an error. That's interesting. Never knew that. So it just takes everything, the remaining. I think that's what it does. And so -2, I could do -1, -2. Yeah. And so sometimes the negative is always good when you're trying to slice from the back. So where are we? Okay, I've done this. And then you can always check the D type, which is the number, and they tell you that we're actually using floats. Another thing that you could do is that you can check the length. So which is what's the length of this array that you're working with, and it'll tell you that the length is 2. So one thing you could also do is no Nietzsche. It actually counts from the back. So I think okay, so this is where the confusion is. So I'm actually replying to someone's question, right? So now remember that it could also count from the back, but the reason why it's taking everything is because of this signs that I have. So if I do this, it's gonna give me one number, right? So this is like saying -1, which is this row, and -2, which is this, and then it's gonna give me this exactly. So if I do a -2, -2, what am I gonna get? Yeah, that's the range operator. Okay. Yeah. Okay. Yeah. So I'm going to get 5. Okay, so let's go. So the next thing that I was trying to do is let me see the time. Okay. If you guys don't mind, we're definitely going to go above the allotted time. Oh, gosh, I have like so many things to cover. Yeah, sure. No problem with questions. I see. Sometimes this is, I'm trying to do this. So the in statement for NP arrays, they're really good. I mean, you have this armory2, and then I want to see is, for example, I can just write a very simple, is 11 in, and then it told me if it's 23 in, it told me it's false, right? And it told me that this is true. So that's pretty good. Another thing also is that you can actually create a range of a number. So you could say range or something, and I can say this is NP array, and I actually want it to give me, so you can actually just create a random array, and I can say I also want this to be float, and then it's just going to create from 0 to 19, which is actually, if you count it, it's 20, right? And then you can always reshape. So I know that this is actually a one-dimensional array, but I actually want to reshape it to some sort of ND array, maybe a 5-dimensional array in this case. And I can say that this is now going to be I can always use a reshape. Reshape is so important. If you're building deep learning models where you need to sort of reshape your tensor types, you're actually going to use reshape. I use it almost every day if I'm working with models, so they're really important. Because it is float and it's also an int. Oh yeah, you can run this. These are extremely basic stuff. You can run it on your Jupyter notebook. And for Daniel, yeah, it doesn't matter. I mean, 8 is int is float, yeah. So now I want to actually reshape to 5 by 4. And another thing also is there are those things that I'm looking at. You can also do them on Colab. So if you use Colab a lot, you can do them on Colab also. So now I've actually reshaped it, and now I'm actually going to have a different shape entirely. So you could see now it goes from a 1D array to an ND array. And then I could say, let me see the shape of what I just created. So the shape, sorry. So I have that already. Right. So another thing that is common is actually list. You could take which dimension is this? So this is a dimension 5 by 4, which is the ND array. So what I did was I actually reshaped it. So another thing I could do is I could actually come here and say I want to reshape it to 10 by 2. Oh no, I did 5 by 4. So I could say 4 by 5, and then it's going to be different now. So you could see. And now I have 4 by 5. Okay. So yeah, I would actually show you. So let's do this now. 5 by 5, right? You can see you cannot. So Okoronkwo, can you see what you asked? So it cannot reshape a size. Yeah, it must actually be the same size when you're reshaping. There are other things you could do, which I'm actually going to come into. I'm going to talk about later. You could actually try to fill the other part with zeros, or you could broadcast. That's possible. But when you're doing reshape, it has to be able to you need to be able to multiply these two shapes to give you 20. So let's go back. Okay. Yeah, good questions, guys. Keep them coming. I might be slow to answer them, but I'll answer them. Another thing is, so let's say we have a simple array. Let me call it A, and this has 1, 2, 3, 4. I like float a lot, so I have an array called A. Another thing you could actually do is that you can directly convert. You can directly convert an array to list. So which means that you could just say A to list, right? And then you could do this. Yeah, you could actually arrange by columns also if you want. Then you have it now. This is actually a list. Another thing you could also do is this is to list, and then you could take list of A, and then you could also have that. Now I have my A to be this, right? Sometimes the periods where maybe you're working with some complex metrics, and then you want to fill everything with 0. So you could do A. I could do A dot fill 0, and then now I have everything to be 0, right? So I could actually do that. But instead of you creating this array and then reshaping it, for example, you don't necessarily need to do all this, right? You could actually come here and take, so you have this one. Another thing you could do is just do your reshape directly from that. So you could say 5, 4. And then with that, you just have like a one-liner. And you could write this. And then, yeah, you can actually take a list and convert it to an array. It's just the other part of it. And then this is the range. Another thing is you could actually transpose this. So you could transpose this. So now all the rows becomes columns. So you could do that. And then you could take an array that you've created, an ND array, and then you can actually flatten it to a 1D array. So and with that you use flatten, and then it flattens it to a 1D array. So you could do that. Then let's go. Next thing I want to cover is they're the same. For flatten, it actually just goes back to a one-dimensional array, quote unquote. And Ogunyemi, yeah, it's the same as transpose. Yeah, no matter the dimensions, it flattens out to 1D array. And flatten, I'm trying to remember what. So when you're building machine learning models in, I think with scikit-learn or whatever, you have maybe, for example, you're doing image classification where sometimes your images because the way image if you want to convert them to numbers, they're actually like a 3-dimensional tensor, because you have something called RGB, and then RGB, those R, the G, and the B, they're all numbers, right? In some cases, you actually want to take everything and flatten them together, and that's where flatten is actually used. Someone actually asked about inverse. I think I'm going to get to a place where you do the inverse. The inverse is extremely tricky because it also depends on the algorithm that they have to do the inverse. I'm going to try to remember what NumPy uses, but yeah, you can definitely do the inverse. You can do the inverse if you've done linear algebra before. You could also take an array of matrix. Remember that it has to be square, right? And then you could, for example, get the eigenvalues and the eigenvectors, which are the characteristics, values, and vectors of this ND array. So you could do that. So But yeah, the next thing I quickly want to do is how do you concatenate arrays together? So, yeah, so you could so let me do a let me call this sometimes I run out of numbers to think to use. Oh, look at me. 5, 8, and let's say 5, 8, and 9, and then let's just call that float, right? So and then so I could actually just do np dot concatenate A, B, C, right? So what I'm doing is it's actually me taking all these are like one-dimensional arrays and I'm trying to concatenate them, and then I can have this. So which means that I've actually concatenate them. So another thing that I actually want to do is that I can come here and say, let me call this X. This is a little bit tricky, but you guys would see. Now I'm actually trying to do a two-dimensional array. And then I can call this, let me do 4, 7, 9. And of course I want it to be float. And then I have 10, 12, 13, just random numbers. 17, and then 19. So, and then I can take this and I can say, oh, let me take a simple method and say I want to concatenate X and Y. And this is straightforward. I could actually do this, right? But also, give me a minute. But also, I can actually concatenate along the axis. So you could see that now it's actually concatenate along the, so there are two axes, the axis 0 and axis 1. Axis 0 means it's actually concatenating along the 0 axis, which is the row. So it's taking this and then it's joining it together, right? But I could also concatenate along the axis 1, which is the column. So I could actually take this, for example, which is what I'm going to show you. And this is always the default, which is axis equals to 0. And I'm going to get this. I could also take the same thing and say my axis should be 1. And then you could see now that I'm actually concatenating along the axis. Okay. We'll do other creative ways. We still have a lot of things to cover. Let me. At exactly 3 p.m. Nigerian time, I'll probably answer some of the questions that you guys have. But let's go to, let's see. And also, I'll probably just send this notebook to, and they'll send it to you guys if you want to play around with it. I know that we have, yeah. Mm-hmm. Oh. So you guys remember that I when I wanted to do the stuff, I was using np.array and I was doing range from range, and I had all. Another thing you could do is there's something called np.arrange. The arrange is actually 1R, remember, and I could do 20, and I could say that my d type is And it's actually exactly the same thing as what I did. Another thing that I could do is I could take this same np.arrange now, but what I want is I actually want it to go from 1 to 20, and I want it to go show me every three numbers, right? So and then I put a comma, and so it's just going to show me 1 because it's the range is 1 to 20, and then it goes every three numbers. So I could say 1, so plus 3, 4, 7. So I could actually play around with that. Sometimes you might want to do another thing is there's something called np1s, which I can say I want to do this, and basically just going to give me an array of 1, and it's going to be 4 by 5 array of 1. I could also do just np1s, and I could say let's just 10, and it's just going to give me a one-dimensional array. So I could do that. I could also do the same thing with creating zeros. And then it's just going to be the same thing. So I could also do that divide 1. You could also create something called and I could call it special 2D arrays. And after this, I'll answer some of the questions, and then I'll go to array mathematics. So special 2D arrays where you could have np.identity. So this is right, and this just gives you an array where. Please give me a minute. Gives you an array where you have all the diagonals to be 1, so it's an identity matrix, right? And then there's something called np.I, and it also gives you an identity matrix. But one of the things you could do is that you could actually shift the identity to be off diagonal. So which is this k? Yeah, you guys are gonna get a notebook, which is this k. So now you've actually just shift. This is 1, so you shift it down a little bit. So which is this? Okay, before I go to array mathematics, I'm probably going to answer a few questions. Let's go back. Multidimensions asked that. Can you explain how? Yeah, you're definitely going to use it in a lot of ways. Wrangling data, playing around with data, trying to convert the shape of data. Eventually, when you start building machine learning models, when you start building machine learning models, you would actually appreciate a lot of these things because then you understand how to sort of play around and structure the shape or the format of your arrays. So you do that. Edna asks that, can I take the special 2D array from the beginning? Okay. Yeah, so these are just the special 2D arrays. So there's something called an identity matrix, which is a matrix where everywhere is actually 0 except the diagonal. So this is the diagonal. So all the numbers in the diagonal, they're actually 1s. And so this is what it is, right? And then np.I also gives you an identity matrix, but however, you could shift it. So you can actually have something called an off diagonal identity matrix, right? So it actually switches this 1 in the diagonal, it brings it back. So I can show you. Let me do 2. If I do k equals to 2, it's gonna be, I'm gonna have 1s here. And we can see, can you see now I have this. If I do k equals to 1, it's gonna be different. If I do k equals to -1, it's also gonna be different. So that's what it is. Okay. Can you convert an already populated array to an identity matrix with only the diagonal? You could, yeah, but that would take a little bit of code. You could actually write a piece of code to change the diagonal to be 1, but that's not an identity matrix because it's already populated, right? And every other place are non-zero. But you could also do that. But which means you want to insert numbers into the diagonal. I think I answered. Can we get a notebook of a code? Yes. Notebook, yes. You guys will get it. Notebook, yes. Is concatenation same as mapping? It's a little bit tricky. In pandas, I think you could map, but both of them they have different ways that they work. With different data types, yes, you can concat with different data types. Is there a way to join without? There's so many ways to join. It depends on the library that you're using. Is concatenation similar to zip function? I am not exactly sure of that. Okay, I think I've answered that. Someone asked about zip function. I'm not sure. I've actually never used the zip function before, but it's possible. Okay. So let's go to just simple array mathematics before I do broadcasting. Is it possible to concatenate two-dimensional array? Yeah, it is possible. But just remember that the two arrays should be the same dimension. Actually, okay. Okay, so let's take, I'm probably just going to use this again. So let's take these arrays and let's say this is 13, and boom, I have this, right? I could do A plus B plus C, and it's just going to add it. I could do A minus C or whatever. I could do that. I could do A times B. So I could actually multiply arrays by arrays. I could do different things. I could do B divided by C. So I could do all those simple array mathematics. And then I could also do array mathematics with 2D array as long as they're actually the same. I should be able to do that. Okay. So the next thing that I'm gonna do is this is actually very important. Is is actually broadcasting with Python and NumPy. So the idea is that let's say that I have this array, this, and then I have, let me try to use this. So I have this array A and B, right? So the way what is it called? The way okay. So the way this works is that if I do A plus B, what do you guys think I'm gonna get? Error, okay. Error. Who thinks Ogemi is laughing? I can see you. Who thinks I'm not gonna get error? Nobody. You didn't tell me exactly what's gonna be. I just want to know if I'm gonna get an error. Okay, said I'm gonna get something plus others. Yeah. Okay, so yeah, that's our Python broadcasting. Actually, it's giving me an error. Wait, what am I doing? Oh, okay, it has to be the same format. Sorry. So yeah, so I shouldn't get an error. And so the reason why I'm not getting an error is that Python, when you're doing stuff like this, what Python does is that it actually broadcasts and creates no error. He actually creates some sort of artificial or some sort of broadcasted extra dimensions for you. So basically what it does is that it takes this B, right? And then instead of this, it actually just, it uses this. So it takes this. And then multiply it like that. And then that's what it uses. So that's the way Python does broadcasting. Yeah, it actually replicates it. The B and then also, I remember I was saying that for math you could do all these. You could also do NP the square roots. So NP the square roots is actually pretty good. Let me see. 909. There's so many things you could do with it. I'm probably gonna just send you. I have a lot of things I wanted to cover, but let's still go. Is this on my screen? Okay. So I actually would do this, and the reason why I want to do this is that someone messing with my screen. Okay, wait. All right, so let's do this. Maybe this probably did. So there's something called floor, seal, which is like flooring, ceiling, and rings. And I'll explain to you guys why I want to do this. So let's say that we have an array Z called np.array, and then let's say we have 6.27, 2.3, 5.4, 1.192, right? And then I call this float, right? And I want to see what my Z is, right? So I have this Z, right? So what floor does is that floor actually gives you the lower value of the integer. Seal, which gives you the upper value of the integer, and then rings actually rounds to the nearest integer. So if I do np.floor Z, what I get is now the lower value, which is 6, 2, 5, and 1. Right? Or let me do 6.7, so I have something greater than 0.5. So let me do this, right? I'm still gonna get the same thing. And if I do np.seal, I have the same thing. So around 7, now 3, 6, and 2. And then if I do rings, oh no, why is it? What it does, it actually gives me the actual rounding. So 6.7 is now 7, 2.3 is 2, and all that. So that's what I do. If you're using mathematical constants, I think someone asked me. So this is I'm just gonna write it here. Floor gives the lower integer. Seal gives the upper integer. And rings rounds to the nearest integer. So yeah, that's that. So that's what they all do. There are other cool things you could do, mathematical constant, np.py. You don't need to type them, you can actually just call them directly, and then you find that. I know I have like 2 minutes more, but I'm probably gonna take 5, if you guys don't mind. Just to quickly cover this. So you could actually iterate through an array. And then the idea is that, let's say that I have my m equals to mp dot array. Have my m. And then, so what I can do is that I can say that for armory in m, right? And I want them in Python 3, I want it to print armory. And it's just going to print each of the arrays for me. And I can also do, if I have, let's say I have, let me take, I have a 2, I have this, all right, let's test this. Let me say n equals to this. And I have this one, right? So I could also do just the same thing, but in this case is n. And what it does is that it just prints each of the dimensions for you, right? You could do that. Another thing that that is always very good that you could do is that, so I have this array, and then another thing that I can do is that I can say that for, you guys will see, this is interesting, right? For A times B, it's just temporary. You can also use any of the loop to iterate through the array manual. So let's say that for A comma B in n, I could actually then say I want to print the value of A times B. So all I'm doing is I'm taking 1 times 3, 0 times 5, 2 times minus 1, and then I could see that. I could also do that like this. And then I could do the lot other fundamental array operations. So with array also, numpy array, you could do some products, you could do the variance, the standard deviation, the mean, the argmin. You could basically do everything that you could think of in terms of mathematical manipulation. So you could do that. So you could use any of your loops through an array. You just, if you don't define it, what it does is that if it's a one-dimensional array, for example, it just takes the individual components in it, right? If it's a two-dimensional array, it takes each dimension, and then it takes each dimension, and that's what it prints for you. But you could actually tell it to you could say for this, because you know that this is what it is, and you want to take each one of them and want to multiply it. So that's that. I have more things to cover, but a lot of the stuff that you guys are gonna need, they're gonna, the materials that you guys are accessing, just go through it. I think I put some. There's some materials where you guys external materials that you can also check. Has anybody's got into the questions yet? So yeah, for the questions, we tried not to make them extremely difficult, but they're very doable, and so I think you guys are in good hands, and this is going to get very exciting from here. So yeah, okay, I think I'm done now.
All right. Thank you very much, Wale. That was indeed a very wonderful session. Looks like we have lots of questions now on Slido. And I absolutely love the synergy of these questions, a mode of technical and non-technical. So if you are here to drop your questions on Slido, the event code again is 22405. And the first question I have here is, how is it like working as a data scientist at Amazon Web Services? Do you work remotely, and how did you go about your certification?
Okay. How is it? I mean, you guys know Amazon is big tech. It's part of the FANG, which is what Facebook, Apple, Amazon, Netflix, and Google. So those are the big five. So it's been very exciting. Amazon has thousands and thousands of scientists, data scientists, research scientists. So inside AWS, the idea is that I have like so many people that if I have questions, it's extremely easy for me, and also have all the tools that makes my day-to-day work easy. So I actually work remotely. And I mean, this is what 2020 is showing us, that everybody can actually work remotely efficiently if you are in tech. So I work remotely, and I would say it's been exciting solving mostly problems in healthcare and life sciences. They've been interesting, challenging, interdisciplinary problems that I wake up every day and I'm happy that I'm doing it.
All right, thank you, Wale. So another learner wants to, I know that having qualifications as a PhD gives you an edge to jobs as data scientist. What chance do I have with my Bachelor of Technology in Computer Science?
So I'm going to say this again. If you're going to be a data scientist, you don't need an advanced degree. Yes, you actually absolutely don't need it. And I'll give you an example. I know that because I am a physicist, I had like pretty good acumen in terms of how to code and mathematics and all that. But also, just like everyone on this call, I am a self-taught data scientist. I've never attended or taken a class in programming or a class in machine learning. Every single thing that I know, I actually learned online. So so you guys need to know, don't be intimidated that, oh, okay, maybe a master's, okay. No. I mean, that's why we have AMOE, right? Because people are trying to find a way of just going beyond traditional classroom and trying to make sure that people can have access to knowledge at any time. So no, don't think about that. Just if you have a bachelor's, you're good. All you need to do is that you actually need to just make sure you understand the materials and you learn. So data science and machine learning, the pace is really fast. I mean, there's some tools that we use now that they were published last year or something, right? So what do you know 5 years ago is different from what you should be using now. So if you like learning, if you like the accelerating pace, then I think you're going to enjoy data science. So you just need to keep learning and keep learning. So yeah, don't worry about that. Everything you need to be successful, you can actually get it without attending a traditional classroom.
All right, Wale. So in addition to the question, someone asked if you could go back to the beginning phase of your data science journey, what will you tell the younger version of yourself to focus on?
Oh, like the younger
version of yourself to focus on?
Actually, nothing. And the reason why I said nothing was that when I started, I actually set out to be a generalist. So a generalist means that I know it's a little bit ambitious, but I actually want to be good at everything. So I want to do machine learning. I want to do natural language processing. I want to do projects in computer vision. And now I actually get to do everything that I want to do. And also I did a lot of things. I had meetup groups that I created. I speak to people. I would have said, tell my younger version to start earlier than I started. That's what I would have done. Maybe start earlier. Yeah.
So here's another question, almost similar to the one I asked previously. So as a beginner in Python, how do I streamline what I need from the vast information available on the internet so I don't become overwhelmed?
That's the answer. So there's so many resources, right? And one of the things that we're trying to do, that Amo is trying to do, is to to just separate the signal from the noise, right? To try to make sure that everything is very structured. I mean, that's why you guys have materials that you go through and you have some resources. I understand there's so many things online. A lot of it can be confusing, but I would say you're actually at the right place. So that's the way for you. If you have like a sort of structured learning process, I mean, that's a good way for you to be able to sort of separate the signal from the noise.
Thank you. And here is one technical question. Please, can you explain negative slicing?
I went through negative slicing like 3 times, so I'm guessing I've explained it again. I'd have to share but I'm guessing the question came when I was explaining it.
Okay.
But yeah, I think the recording is going to be available, right?
Yeah, definitely it will
Okay,
be.
so they can, yeah, you can actually go back to the recording. And just think of positive slicing is you just going forward. Negative sliding is you coming from the back, right? So let's say, for example, I have an array and think about it, I have 1, 2, 3, 4, right? If I want to see what, so let me say the array is Toby equals to 1, 2, 3, 4. If I want to see Toby of 0, or Toby 0, the indices, the index in this case is 0, is actually going to be the first one, right? Which is the 1. Toby, the index 1, it's going to be 2, right? But if I say Toby, the index -1, it's actually going to be 4. If I say -2, it's going to be 3. So basically, negative indices means you're actually coming from the back. So positive, you go to the front. Negative, you're coming from the back. That's it.
All right, thank you, Wale. I would love that we take these 2 questions together because they are somewhat related. So what do you think is the future of data science and machine learning? And you've answered this before, but this also came in as an entry-level data scientist with no experience in programming or coding. What does one need to do to become an expert in this field?
Okay. So the first one is that what do I see the future of? I mean, the future.
Data science and machine learning.
I mean, the future is exciting. The future is incredible. I mean, so the thing is, I've heard a lot of people say that data science is a bubble, and at some point the bubble is going to burst. Right? It's not going to be very important, but I don't think so. And a lot of reasons why I don't think so. I mean, people said this 5 years ago. Think about everything you use in your day-to-day life and how they have some sort of data science or machine learning underneath the process. So if you watch Netflix, right, for everything you click on, one way or the other, there's actually a model. There's a machine learning model giving you recommendations. If you go to Conga.com, they actually use machine learning models to recommend products that you should be buying. And they actually want to continue, they want to improve it. If you go to Paga or OneFi and you want to get loans, for example, they have models that actually does credit, that actually tries to model or predict what your credit risk would look like. If you use Facebook or Instagram, every single ad that you get, which is, for some of them, they have to make like 1 trillion decision in a minute. They're all driven by machine learning. So the future is actually very bright. There are people also using machine learning and reinforcement learning to build cars that can drive themselves, self-driving cars, right? And there are people that are solving problems in social good also with data science and machine learning. So it's actually here to stay. In terms of entry level, I mean, becoming an expert is not a day's work. You need the experience, but I would say learn as much as you can, but more importantly, so if you learn a lot, try to have a portfolio. So build a project, put your project or whatever you're doing, put it on GitHub. I know that for this session, for Amoy, for this internship, it's like five different modules, and then there will be the last 3 sessions actually where you guys have the opportunity to build 3 different projects, to actually have a portfolio. And so it's extremely important for entry level for you to, okay, oh, I took this course, I learned this, I did that. When I'm interviewing people, I'm fine with you saying that you took courses, but I would also ask you, what did you do with it? What have you built with it? What project have you worked on? So that's important.
Yeah, thank you, Wale. Now, this is specific to cloud. So someone asked, what cloud platform knowledge areas go in tandem or complement data science? Is it advisable to seek competency in both?
Yeah.
Wale, did you get the question?
Yeah, I get it. I work
Thank
cloud. Yeah. So I mean, there are a lot of cloud platform knowledge areas. So there is, I mean, you guys you're already using cloud if you're using Google Colab. So there's Amazon AWS. There's also Google Cloud Platform. There's Microsoft Azure. There's every one of them. So you can actually pick anyone. A lot of them they're paid, but they also have free versions. So AWS, we have a lot of free stuff that you can play with AWS SageMaker. And so the idea with cloud platform is that you want to foster collaboration, but also when you're trying to deploy machine learning models, it's very difficult for you to do traditionally. So a lot of the big companies, they're actually using a lot of these cloud platforms. So I think maybe Google will give you maybe I think $300. I think a $300 free credit. So you can play with any. Azure will also give you something I can't remember. So you can play with them. AWS, GCP, Azure. Use some of the free credits and don't go above it. But I think they're what you can. They are definitely worth it. Yeah.
Thank you, Wale. So I've been seeing some questions as regards the project, and let me quickly address it. So when once you're done with with your quiz, you are required to submit a GitHub link of your project. And what should contain in that GitHub repo should be the steps you took to actually get the answers that you chose in your quiz. So that has been addressed. You need to submit the link to your code so we vet with the result you get in your quiz too. And while this is specific to lesson 2 and 5, so someone asked, how do I relate to with lesson 2 and 5 of the electricity data utility sets?
Lesson 2.
Considering that in the lesson just few values were used, it's a bit cryptic.
I don't know.
It's a bit cryptic. Yes, so I think we've covered. Now this is one. Can someone without a strong mathematical background succeed in machine learning and data science?
That's a good question. Yeah, that's yes, you can actually succeed. Because I mean, so I can give you like for example, some of the best data scientists that I have worked with or that I have met, they're actually people with non-mathematical degree, although they have like quantitative aptitude and they have some sort of quantitative background in their stuff. But I'm talking of people with degrees in like psychology and sociology. I actually knew someone that did a graduate degree in quantitative political science, and he's an extremely brilliant data scientist. And I also remember that data science and machine learning is not only about writing code and the mathematics, but it's also about asking the right questions. And also, you for example, building a model and saying, oh, okay, I don't think this is right. Let me try it. So some people, they're probably good with the maths and the coding, but they don't ask the right question. All right. So what actually distinguishes a good data scientist from others is the ability to ask the right questions and also the ability to be able to answer them with data science.
All right, now this is the last question. Now, answering the right questions, can you differentiate between programming and machine learning in a relatable way? And also, how can machine learning be applied in the insurance sector, possibly in pricing of an insurance product?
I mean, so I would just say data science encompasses a lot. I mean, programming, statistics, experimentation. It depends. Sometimes in data science, you also write queries like SQL. So I would say machine learning is part of data science. For insurance, I have friends working in some of the biggest insurance companies. A lot of they actually build machine learning models to make a lot of decisions, around pricing, around just around different things. Sometimes they might even predict if a customer would file for a claim or not. And so with that, they can plan ahead. So yeah, it's actually used in the insurance sector a lot.
All right, thank you, Wale. Now, a quick synoptic of what was discussed. Wale covered questions, lots of questions as regards the operations in NumPy, regardless of the dimensionality of the array, such as slicing, type conversion, length of an array, range operator, reshaping, broadcasting, concatenation, and converting of arrays into lists. Now, Wale actually broke the table again, as I said from the beginning, and it looks like we've covered all the questions and exceeded our time. Wale, is there anything you'd like to say before we wrap up?
Probably just one last thing that you guys are probably a few days or a few weeks into the program. This is just the beginning. There are a lot of things to learn. Don't be discouraged. If you have questions, ask questions, discuss with your friends, discuss with your colleagues, speak about data, and also be enthusiastic, and you guys would enjoy it.
Great. Thank you, Wale. Thank you, everyone. We appreciate you for being here. Thanks again for joining us today, and we'll see you next time. Bye.
Yeah, sure. Thank you, guys. See you.